The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon. This is Mark from SolidCAM. Hope everybody's safe, either at home or if you guys are essential and you're at work, hopefully you guys are okay at work, busy. Today is SolidCAM Live. We're going to be doing a half-hour free training session for everybody in attendance. Myself, you probably recognize my voice. I'm the second voice on SolidCAM University. I do the tips and tricks videos. And with me, as always, no need for introduction, we've got Kevin. How you doing, Kevin?
Good, how are you?
So this time around, I'm taking the driver's seat. So what we're going to do is, like I said, 30 minutes. We're going to do a quick kind of overview of someone's questions that they sent us. And we'll start with, actually someone's in attendance sent us this question. And it's basically, how do you do multiple parts on a single sheet on a kind of a router machine? In this case, it's a thermoid. So let me just get rid of this little title page. There it is. Okay. And some of you might actually recognize this part from the part askew video that's on the YouTube channel. It's still askew. I didn't actually change it, but what I'm doing here is I have a part that is basically just a flat part like that, and I'm doing it on a large sheet. This is about a 5-foot by 5-foot sheet. And basically, how would you do this? We don't have the ability to do nesting, but we do have the ability to do transforms. So what I can do is I can just take that one part, program just one instance of it, and just translate it across the part in a linear array. But let's take a look at what I've done to the part. Basically, I've just done this profile toolpath using a 1/4-inch tool just to do those holes there, and you can see that it transforms it across the entire part. Likewise, since this will be on a router, I don't want that piece to actually fall out of that sheet of material. So I've used one of the Toolbox cycles, and anyone who's seen the Toolbox cycle video from KevCam knows that in the top left corner here, you can just click on this, this array of options, and I'm using the one called temporary bridges. And what temporary bridges requires you to do is just choose the outside of the part that you're actually going to hold in place with those temporary tabs, those bridges. And that is just simple profile or pocketing style geometry. It's just the outside of the part. And then from there, I chose my tool. In this case, it's just 1/4-inch end mill. Levels, very similar to what you would see in any of our 2.5D toolpaths. I actually have it starting at the top of the stock, going down to the bottom face. And again, that color coding indicates associativity to the bottom face. So this toolpath will always start from the top of the stock and go down to the bottom of the part, regardless of what that number says. And because this is on a router, there might be a spoiler plate on the bottom. I'm just going to go an additional 5 thou just past there, just to make sure I eliminate any kind of flash on the bottom. But like all our 2.5D toolpaths, in the technology section is where you're going to see the main options of this toolpath. And in temporary bridges, it works very similar to profile and pocket, where I'm just going to choose the side of the tool. So because my cutting direction is going along the tool in that direction, left side means I'm on the outside of the part, I'm doing climb milling. We have the same options here of roughing. In this case, I'm just going to go full depth of cut. So that 1/4-inch sheet of material plus that 5 thou is 0.255. And then I'm just leaving nothing on the wall. I'm just going to kind of cut this thing right out, cookie cutter style cut. What we're going to see with the temporary bridges is this section right here, where I can tell it the bridges I'd like to leave behind, the tabs I'd like to leave behind. If I clicked on auto, it would automatically space tabs along the part. I can provide different spacing, number of tabs, and whatnot. I've actually opted to do manual with this one because of the unique shape. So if I click on bridging, you'll see that basically I just chose points along the flats. So it records those positions. Those could be the center of each edge. Those could be distances away from certain vertices and whatnot. Essentially, it is just wherever I wanted it to be. And you can sketch that as well. You can sketch points or you can do dimensions, whatever you need to do. Because we're creating bridges, I'm actually telling it the bridge width and the thickness. Now the thickness, this is actually more than the thickness of the part. So I'm actually just basically telling it just to leave the entire thickness of the part. But this bridge width is actually pretty interesting. If I show the wireframe, that is just leaving behind material. So of that sheet, I'm actually leaving behind that width of material to act as a bridge. If we take a look at that in the updated stock, It actually leaves behind that bridge there. So that width right there, at the closest point of those two things, is basically the width of the bridge that I told it inside the toolpath. Obviously, we're using an end mill, so it's going to leave that kind of cylindrical face there. And then because I just did a wireframe kind of profile cut, those little slots, those little slugs are left behind there. Now, the thing I like about the temporary bridges toolpath is not only does it do this for us, so we tell it where the bridges are, we tell it how how thick and wide we want those bridges to be. But if you do a save and copy, you can just take that same toolpath, and then as soon as you check the box that says remove bridges only, basically it just goes around and just removes just the bridges. Now that thing will just fall out of the sheet, or it'll just become its own slug, and then now you collect the part. So we're doing one part on this entire sheet of material. And I've done that using transform. So if we open up just one of these transform commands, we can take a look at how that was actually done. So I just click edit. I've actually opted to use the translate option, translate matrix. In the matrix, it allows me to tell it how many instances I'd like to create and distancing between those. So I've actually done 5 in the X direction with a spacing of 12 inches. And if we zoom out, we can see a preview of what that is, just showing us that going across there. So those purple squares are basically just representing the toolpath. And then in the Y direction, I've told it to do 6 instances with 10 inches apart. Now, if we look at the entire thing, there's our 6 with 10 inches apart. That's fully under your control. But if you look in the top section here, I've just done it in the current position, in the current coordinate system using the X and the Y axis. But I could have chosen any other coordinate system. So if I had maybe, again, a part that was skew or a part that needs to go in a vertical direction, I could choose any one of these coordinate systems. Maybe it's a 4th axis part. And I wanted to do a linear transform in whatever direction in that coordinate system. I could check that box and choose whichever coordinates, whatever axes I'd like to use for my axis 1 and axis 2. If it's a custom axis, still under Mach 1 position 1, let's say, but it's a diamond shape or a diamond array or something, I can just choose my own custom axes here by choosing 2 points to define a line, and then that direction becomes the axis. So I have that ability as well. And then if you look in the bottom right corner, similar to what you would see in our drilling toolpath, I can sort the instances. And I've actually opted to do kind of like a serpentine kind of sorting here. So if you take a look at our wireframe here, I'm going from left to right, then I go up, right to left, and I just keep going across. That's just to minimize the travel of the tool. But if you click on sorting, you've got all these options here for whatever it is you're trying to do. Okay, let me exit out of there. Let's take a look at this real quick in a Solid Verify. So it does the first couple holes, and there's a slug there. And again, very similar to what we've seen in a previous CAD/CAM video, when you have multiple solids on the screen, you can actually tell it which ones you'd like to get rid of. So in reality, that slug is either going to go flying off the table because it's just a little chunk of wood or steel or whatever this is. But it might, by leaving it on screen, it might cause a crash or a gouge. It might think it's a crash or a gouge. So what you can do is you can just click on this and say, okay, that right there, solid 3 represents those guys. I want that off the screen. So I'll say yes. And then when I exit, that particular one is off the screen. And I could choose all the individual ones. And then going forward, the more solids on screen, I can select which ones I'd like to keep or which ones I'd like to get rid of. Okay, it looks like there's a question. I'm just trying to expand this menu here.
Yeah, so what Jake's question is, he's wondering if he can do that array of pattern, but skip one just in case there's a knot in the wood or a bad piece of material there.
Perfect question with the linear translate. A lot of people don't know or didn't even pay attention to something like this. So let's say I choose all 3 operations, and I'm going to do a linear translate. I'm going to go translate, but this time instead of choosing matrix, I'll choose list. Now with list, I have the ability to actually almost do it like coordinates. So if I include the original operation, there's our 1 at 0, 0, 0. I want to skip this one here. So I'm just going to go to the next one. So if I had spacing of 12 in X and then 10 in Y, well, I just have to go 12 In Y, we're just going to go 0 because I'm not going to go up to the next row yet. And then in Z, we're going to go 0 as well. Actually, what am I doing? That should be 24 because I want to go to the next one. And there you go. So now I've skipped wherever that knot was. Now this requires you to know your material to know that the knot was right there. But basically, in the programming, you have the ability to now plug in as many of these as you need to. So again, we can go to 36, like that. If I want to jump up to this one here, let's say that is about 24, and then 20 because we had a spacing of 10. We'll click enter, and we jumped there. So it's more of a coordinate-based translate, but you have the ability to just tell it where you'd like to go. So this is also useful if you have a previously cut piece, a sheet of material. So now there's a whole chunk missing over here. There's no point in doing a whole array where I'm just going to be cutting air over there. Now that's using this. If I remember correctly, and maybe Dr. Kev can tell me, is there a way to do that in the matrix? I can't remember if there's a way.
No, there's no way to skip it in the matrix.
Yeah, so I guess it's translate list, the best way to do that, to skip the instances.
And to make it a little bit easier for you, Jake, what you could do is do a translate matrix first and do maybe all the ones going up in your Z, and maybe for the last couple, then you could just do a list, and that way it would avoid some time for programming for you that way as well.
That's a good suggestion as well, because using matrix, it is a repetition. So if you know that all of these are okay, and let's say all of these are okay, except for maybe these last two, then like Kevin said, you could just do all of these, this entire array. And then when you do your list-based one, you can tell it to jump over here. And there's nothing saying that you can't do nested translates. You can do in one direction, and then you can tell it to copy it maybe just for these 3 rows here, or 3 columns here. So you can do a translate, and then a translate on top of a translate.
Yep. So you guys can have as many translate, rotates, all inside of this transform dialog box. Now, let me ask you, Mark. So our first one, we machined out our holes, and our second one, we did our nubs. But what would happen if I wanted to put bolts in there before that last operation machined off those bridges?
That's a good question. That's a really practical example. Once we drill these holes, obviously now we can put the bolts in there to hold the piece so it doesn't go flying when we take the bridges off. Well, if you want to pause after the operation, let's say before we do remove bridges, we can add, where is it up here? We can go MCO, and let me just bring this over. And if we wanted to, we could add either miscellaneous code, and then we can just do whatever we want in terms of maybe adding an optional stop and then a little comment that says, put the bolts in there, whatever. If your post is set up to do so, you might be able to just come over here and say machine stop or optional stop, whichever one your post is going to output the proper code. And then that will give you your optional stop or your pause, and then you can actually put the bolts in there and then continue. If you want to make it actually part of the entire setup, so you actually see it show up in the Solid Verify, again, a little more practical example, then you can actually put this under its own machine setup. And that machine setup can still be under Mac 1, but in this machine setup, we'll add a fixture that represents the bolts. So if I had 3 models that represented the bolts, I could select them on the screen after they've been mated to the solid. And then under this machine setup in our Solid Verify, the bolts are there. We'll see them. We'll know if we're colliding with them, if we're retracting enough when we reposition. And that's just a representation inside the software. So it depends on what you need to do on the machine. If you want to go through the trouble of creating a machine setup to show all that, you can. If you're just looking for a pause, then you can do that as well.
Great questions, guys. Any other questions that we could point out for just this transform and toolbox cycle training one? Yes, so it came up as a question as if you can do a rotate, and yes, you can do a transform rotate. So if this part was, this would be a very large part, but if we wanted to rotate this around an indexer, you could copy this around an indexer as well. That does come up quite often, especially on drilled holes or
you wanted to rotate the part, technically you could do some, if you were to set up a, I don't know if you have to set up a dummy coordinate system or if you can just click a point, but if you wanted to rotate that and then translate it, there's a way to rotate it, suppress it, and then just transform the rotation, and then you would have rotated versions of it as well. It's just a matter of nesting your transforms.
So the question came up, is if we can do this transform for multiple vices. So instead of doing all in, I think this is what he's getting at, is instead of doing it all under one coordinate system, could we do it under Mac 2, Mac 3, and Mac 4? So let's say that part, that just that one bracket you had sitting in 4 different vices.
Okay, so let's set up some other coordinate systems to show how that works then. So we'll just right click here. Let's go transform copies. And by the way, you can do transforms on your Mac positions as well. That's what I'm basically doing here. So it only has translate and fourth axis because that's probably the only ones you're going to be needing, but you have the ability to do that. So let's say we do a translate of Mac 1, and let's create an array of 4. So we'll do 2 instances, and we'll put a distance between them of, let's say, what is that, 5 feet? Let's put, we'll do 6 feet. And then we'll do 2 of that. Actually, no, not 6 feet. That, this is in inches. Okay, so do that, and now we have a Mac 2, Mac 3, and Mac 4, 6 feet apart. So now we have different coordinate systems. Let's say these are under different coordinate systems, different vices, setups, whatever we're looking for. Well, in the transform command, you actually have the ability to do a Mac-to-Mac transform, or in this case, it's called coordinate system. And it's very simple. Once you have the coordinate systems on screen, let's just say we include Mac 1 as well, I can check all the boxes here. I will now transform these toolpaths to each one of those coordinate systems. I have them in this nice little linear array here, but they could be all over the place. They could be flipped 180 from each other. In the case of, let's say, a horizontal machine or a tombstone, you could have these on opposite ends of the tombstone. These could be, again, like I said, they could be flipped 180 from each other. So maybe X is in this direction on this vice, but then on the other side of the table, maybe I have the thing turned this way. What you're doing here is you're using the coordinate systems. As long as the coordinate systems are assigned to the part in the same orientation, in this case, X is along this edge, Y is along that edge, then this will transform in relative terms. You'll see once I click save, I mean, there's a lot of toolpaths here, so let's give it a second to calculate. But now I've done all these parts on the other sheets under the different coordinate systems.
And the nice thing about doing it this way is each one of those sheets have their completely own work coordinate system, so you can have work offsets for each one of these vices or each one of these tables.
That's a very important point, because I made these 6 feet apart, but they're not really 6 feet apart on the machine. It's just inside the software, I've told it that this corner here is where I'd like to take the reference point from. But these could be anywhere else on the machine.
Yep. Great questions, guys. Is that what you're looking for there, Pierce? Perfect, perfect. Do we have any other questions, guys? Not seeing anything come through, so I see we have a lot of attendees, which is great to see everyone in here. Trying to see here. I think that kind of about wraps it up. Would you say, Mark?
Yeah, I mean, no other questions. If you guys have any other questions, this is a daily training webinar that we're doing for this week. So every day at 2 p.m. Eastern time, we'll be answering questions if they come along. If not, I'll be reviewing some stuff that I might have done in the past. If you guys want a more in-depth look at some of the videos we've done in the past, maybe we could do a live version of it. If you have anything that's pressing now, I mean, everyone's working on something now, so you probably have a question that you need answered now, or maybe just it's come up in the past and you never had a chance to ask us. Well, here we are. So now's the time to ask.
Yeah, send those ideas. If you guys want to see something or have an idea that you want to see in the SolidCAM Live, send those over to Mark, and we will get those added in right away. We do have a couple more questions that came through. Jake's wondering if you did a rotate to utilize a little bit more of your space. Could you use the transform rotate for the one part and then transform it out on the sheet?
Yeah, so when you nest your transformations, you can pretty much do any combination of those different things. So if you wanted to do a rotate and then a translate, you could. Now, the thing is, it's not nesting as in what we refer to as nesting in the sort of CAM industry, where it's going to find the nice little nooks and crannies to shove all these things together. So what you're actually doing is you're self-nesting. You're going to rotate it and fit it to the part yourself. Now, my recommendation is I find it easier to do that aspect of this inside SolidWorks first, and then bringing it in here and then doing the transform. Because if I try and rotate it here and then translate it, I'm not really going to see it until I do a simulation. Whereas if I actually create the target model and then I see exactly how this thing is fitting into itself and then translate it, I have a better idea as to what I'm programming. But both are possible. Let's see if I can maybe pull one of these off then. So let's say we just do one of these. I'm going to take all the transforms off. Okay, and then we'll just calculate that. And then for now, I guess we'll suppress these as well so we can see what we're doing. So we have one toolpath, it's just doing the holes. Now let's go to translate. If we do a rotate, we have similar options as what we had before. We have delta, which is essentially just like matrix, and we have list, where we can actually give it coordinates. And this actually might be what we'd like to do here. So let's just include the original. And then let's get rid of that. So angle step, and then let's see. Actually, I thought there was a translate and an angle on here, but I guess not. But the rotate point is what we want. So let's just choose a point. Let's say a point maybe like that. And of course, I'm just freehanding this, so that's probably really going to mess up. But let's see. Let's do 180. Okay, so you can see that it's already rotating around that point like that. So this is what I was saying. I probably, in reality, would probably model this inside SolidWorks so I can exactly see how that fits. But there's the rotation around. If I had maybe like a center point or something like that, I can get this thing to really line up. And then from there, let's just say we choose that one there. Then we can put on top of that a translate. So let's just do like we had before, 5 by 12. And then we won't include the original operation. So one is facing this way, and then the other ones are flipped. So we've got the original one there, and then we've got the bottom one there. So I'm doing here, let's open this back up. Let me just get that translate off first. Let's just do the rotate first. And now we're seeing the live part of the SolidCAM Live. Let's do this after. So it becomes its own operation. And actually, I want to suppress the original. No transformations. There's a transformation right there.
I think you'd want to do a translate now.
Well, I wanted to get a copy of it as the rotation first, and then translate the copy.
Okay.
But let's see, no transformation is defined. All right, let's get rid of that then. So take the transformation off. Let's go back, do transform as a new operation. Then we'll do a mirror, not a mirror. We'll do a rotate, delta, mirror point. Let's just choose that point right there, and then I'll just drop it a little bit further. So let's make this maybe 2. Okay. And then number of rotations, do 2, angle step, 180. So rotated, let's change the rotation point. So rotated around that point doesn't really look that great though, does it?
Yeah, it looks like it added, we got 2 of them in there. And this kind of goes to, you can definitely muscle through this way. But Mark, I think let's go ahead and cancel this and just drag and copy that part and do it through SolidWorks, where you hit the hold the control key and on the part itself. So now what Mark can do is he can come in here, and this is kind of where I think it would help you out, Jake, is now we can rotate this part, get it exactly where we want it, and we only need to do it for these 2 parts. And then once we got these 2 programmed, then you can go and do that transform throughout the entire sheet to really utilize that space for you. So it makes it a lot easier to do because you can actually see the physical model itself versus just trying to go off of toolpath itself. So
yeah, one thing I always forget is the difference between the SolidCAM coordinate system and the SolidWorks coordinate system. So that's why this guy flipped in the wrong direction. Let's do this again. Grab this guy again, bring it on screen. There it is. Okay, let's get that top view. Rotate component. And we'll make sure to do it around the y-axis this time because we're looking at the y-axis of the SolidWorks coordinate system. So if I do this as 180, there it is. We'll just drag it wherever we like.
Just like that. So
just like that.
You guys can see this is a much easier way. So now Mark could just go through, and actually, Mark, that's kind of one of our next questions is how do you get to that toolbox cycle?
Oh, the temporary bridges?
Yep.
Okay, so it's like you would in pretty much any other toolpath. Either you can go up to the tabs here, and we can go to 2.5D, toolbox cycles, like that, or you could do it the old way. Just right-click, add milling operation, toolbox cycles. And then to get to the temporary bridges, once you're in toolbox cycles, top left corner under technology, all the different features are here. And these are all unique features. They're still basically working the same way as profile and pocket, but these are more specialized for the different features you see on screen. So let's do temporary bridges. And our geometry for the temporary bridges will be these 2 parts. So that one, I guess I should have mated them correctly, but because we're inside of a 2D toolpath, it really doesn't matter. I'm just going to choose these edges here. So there's one, and then this edge here. There's the other. And it gets projected to the tool plane. So that's why I'm saying it really doesn't matter. I mean, for visual purposes, I probably would mate this better, but for what we're about to do, that is projected to the tool plane. I'll just make sure I put proper levels, and then this can get G-coded. We can put it on the floor, and then I'll worry about the specifics when we need to. But let's go to here, and we'll grab my same tool, levels. So we'll go to the top of the stock, and then the depth. Well, the depth, I'll just make sure I choose the bottom of this part. And then in the delta box, I'll just go that incrementally a little lower than that. Under technology is where you see the specifics of the toolpath. So since we're doing temporary bridges, here we are. I'm going to tell it to do a 0 depth of cut. Really, I mean, we're just going to go through this 250 sheet of material anyway. So depth of cut, there's our 0. And automatically, no, we'll go with manual. Bridge width, let's give it 250 bridge. Thickness, that's more than the thickness of the material, so we're definitely going to get just the remainder of the material. And then in terms of positioning, let's position it around the part. So I'm just going to freehand it on this one, and then probably on this one, if we could snap to the center point if we had the snap on here, but I guess I don't have my snap active. And then let's do temp on that one, and then here and here, and then maybe here. And then if we just save and calculate, you can see it's leaving those bridges behind. Take a look at that in the updated stock. Let me suppress this guy because that's just taking out the entire thing. Let's see. So there's a bridge. There's a bridge. Let's see. Let's do a quick CAM part cleanup on here.
I think when you copied it over, because it was a design.
It was, what do you?
So our stock and our target aren't jiving because we didn't update our target or our stock as well. So that's why it shows the updated stock just being a little bit off.
Oh, I'm just looking at the fact that the temporary bridges, it seems to wipe it out right there. But let me correct my target here. Let's go to target. We'll include that solid there. Let's actually mate these a little better. So we'll go mate. And I'll just make this face and this face coincident. Kind of just bring that guy back to where it was. Okay, so sensitivity is still there. Same calculate. Yeah, so that should be some material behind now. I'm just looking at this, it's still cutting there, but maybe I'm not missing what I did there. Let's take a look at this in Solid Verify, and then we'll see what we've done. So we've self-nested in this case. So using the SolidWorks functionality, we've actually added a copy of the part in a nice little nested position there. And then these two parts, basically one toolpath, we could do a transform on that, and then that basically will self-nest the toolpath.
And that way you guys can see the exact spacing. And with what Mark did, he represented the entire sheet of plywood or whatever you're cutting there, so you can definitely utilize that before you run out on the machine. So.
Yep. And in reality, if you were to only cut a few of these and you want to save this stock for another operation and you want to set it up, you can actually save the stock from one SolidCAM file and use it in another SolidCAM file. So you could save this if it's important. Otherwise, you could just save it. You could do so with a 3D model from SolidWorks and achieve the same functionality. Just basically, you can get this sheet of plywood, maybe do a cut extrude inside SolidWorks, and then it would represent almost the exact same thing. But the idea is you can reuse your stock solids from one file to another.
Yep.
Okay, let's see. So we're about, I guess we're at the end of the session for today. If you have any further questions, let me see if I can get you my email in the chat.
And Jake, we're gonna save your question for possibly tomorrow's SolidCAM Live.
Okay, so that's my email. And otherwise, if you don't want to use my email, Kevin's email is always on the KevCam videos as well. So you can always send us your requests, your questions. I'm also available for our online training as well. This is basically a free version of the training services we provide on a regular basis. So contact your account manager if you want a much more dedicated one-on-one training. If you weren't familiar with that, that's something else we provide, either with SolidCAM trainers like myself, Kevin, some of the other guys on the team, whoever is available to help you out in the time slot that you have available, because not everyone's in the Eastern time zone. We can always help you out with any questions you have, any topics you want to cover in an online fashion, similar to what we're doing here. But it's like Kevin said, just send us the questions, and we'll probably do it tomorrow or any other day through this week. So we'll end the session now. Tune in tomorrow at 2 p.m. Eastern time. We'll do the next set of questions, next set of topics that come up. Everybody stay safe, wash your hands, keep busy so you don't go crazy. Netflix is great. We'll talk to you guys tomorrow.
All right, see you guys.